Hi! In this video, we'll be talking about probably the two most important terms in our study of motion: speed and velocity. So speeding, how fast something is going. All of these are words that, again, we use very commonly in our day-to-day life. So let's look at a couple familiar examples here. So we see our car speeding down the road, flying off into the guardrail. We also have our little snail here crawling towards the finish line. So think for a moment to yourself, which one of these objects, the car or the snail, is traveling at a greater speed? It's probably pretty obvious to you that the car is experiencing more or greater speed. So try to use these two as your example to pause the video and think of your own definition of the word speed. What do we think that actually means? So when we say speed, specifically in the context of physics, we are describing the distance that an object travels in a certain amount of time. We use speed when talking about motion and in physics to describe how fast an object is moving. This is why you were able to look at the car and the snail and say that car is certainly moving at a greater speed or is traveling faster. The units that we'll be using for speed are meters per second. Meters being a distance unit and seconds being a time unit. Making sense because we know that speed describes distance traveled per unit time. Now, understanding the definition of speed, let's look back at our examples and see how it makes sense based on our definition that this car is traveling at a greater speed than the snail. So we can see here that this car is traveling a greater distance in a unit of time than the snail is. The car is going much further every second than the snail is, hence why it is traveling at what we call a greater speed. In this example, the car's speed is probably going somewhere around 35.76 meters per second. That's right around 80 miles per hour. Whereas my little snail is only covering a very small amount of distance every second, traveling probably somewhere in the range of 0.005 meters per second. So in addition to speed, we also have the term velocity. Very similar to speed, but we should certainly understand the distinction between the two terms. So velocity, just like speed, describes the distance an object travels in a certain amount of time. Velocity, however, in addition, describes the direction of the motion. So velocity gives us that one additional piece of information, which is the direction that the motion is going in. At our level in middle school, we will be able to use velocity and speed interchangeably. Because of that, the units for velocity are also meters per second, again, a distance per unit time. Now we can see, again, my car and my snail example. We know that the velocity of the car is higher than that of the snail. We know that it's traveling at a speed of 35.76 meters per second, but to make it a velocity, I would also include information on that direction. So I might say it's going 35.76 meters per second south, whereas the snail is traveling at a velocity of 0.005 meters per second in the direction of east. So now that we know what speed and velocity are, let's talk about how we will actually be able to calculate them when the appropriate information is available. So in order to calculate velocity, we want to use what is called our velocity formula. Our velocity formula tells us that velocity is equal to distance over time. You can also write that as v equals d over t. So now let's look at a quick example of using our velocity formula to calculate the velocity of a moving object. So our example says that the Perseverance 2020 landing device leaves orbit and falls 1,000 meters towards the surface of Mars in 30 seconds before its reverse thrust packs deploy. What was the landing device's velocity as it fell? So this being our first example, it's pretty straightforward. So we know in order to determine or to calculate velocity, we will need to know the distance traveled as well as the time of travel. This example tells us directly that the distance traveled by the landing device is 1,000 meters and that the time it took to travel that distance was 30 seconds. So now all we need to do is plug those values into our velocity formula, v equals d over t, which will look like velocity is equal to 1,000 meters over 30 seconds. If I do the math, that comes to 33.33. I let my units follow me. Meters divided by seconds gives me my velocity unit of meters per second. That tells me that my Perseverance velocity was 33.33 meters per second. And remember, to make it a velocity, we want to make sure that we include that information about direction. So I'll also say towards the surface of Mars.